And first of all, welcome everybody to this new meeting of IARPC, Physical Oceanography Community of Practice, as Mandy already said. And just briefly, for those who are new here, IARPC is the Interagency Arctic Research Policy Committee. The goal would be to bring together leaders from 18 federal agencies, departments, and different offices, and with the goal to enhance collaborations on research within the Arctic region. This is the Physical Oceanography Community of Practice, and our main aim is to coordinate research for the physical oceanography in the Arctic Ocean. The plan for today is to discuss how our community of practice can contribute to the success of the Biennial implementation plan. This is a plan which has been recently released. You can find it online on the IARPC website. There is a link on the webpage. And in particular today, what we will do is to hear from the program managers, and we would like to hear their opinions about what are the most important research directions for our field, for Arctic physical oceanography. Our first speaker will be Serena Stella, the IARPC program manager, and we will hear about a brief overview of what the Biennial implementation plan is and what are the deliverables that our community can provide and can contribute to. Then we will hear from three program managers. In particular, we will hear from Thorsten Marcus from NASA. Thank you, Thorsten. From Danielle Dickinson from the North Pacific Research Board. Thank you again, Danielle, and from Sandy Lucas from NOAA. And of course, thank you, Sandy, for joining us. Again, the goal, what we would like to hear is about how your program is planning to support the physical oceanography research, and information you might have about that is of course very welcome. And after after hearing from you, what we would like to do is to invite everybody from the community to express their ideas on how we could best contribute to the plan. As a reminder, the goal of physical oceanography community, the contribution of the physical oceanography community can give to the plan is about Arctic system interactions. These are the main point, but the main priority area. And we would like to contribute to the fundamental activities, what are called data management, as well as monitoring, observing, modeling, and prediction of the Arctic Ocean. I think we can start with Serena, if you're unmuted. I don't know.
Yep, I have some slides to share as well.
So thank you very much.
This up. Can everyone see my screen okay?
That's great, thank you.
Yeah, okay. Well, hi everybody. Thanks for the intro. My name is Serena Stalla, and I'm the implementation director for IARPC. And today I'm just going to provide a short overview of the biennial implementation plan and go over some of the areas that might be most relevant to the physical oceanography community of practice. And I'll start with some very general background, which I think most of you are probably quite familiar with. But just to take it back to the beginning, in December 2021, the White House Office of Science and Technology Policy released the IARPC Arctic Research Plan to be implemented between 2022 and 2026. And many of you participated in this plan development effort. So we're very grateful for that and for your continued engagement. And the Arctic Research Plan was written as a high-level research strategy to address emerging research questions about the Arctic. And it presents a research framework with thematic goals that kind of outlines a vision for federal agencies to address these emerging research questions. And then the Arctic Research Plan itself is implemented through biennial implementation plans, which outline very specific research actions and research objectives and deliverables. So we're currently implementing the first biennial implementation plan, which is going to be implemented through fall 2024. And again, like you'll probably be familiar with this framework diagram, which illustrates the structure of the whole Arctic Research Plan. So like I said, it's written as a high level strategy that outlines research goals. These goals are linked to four priority areas, which are in the red fan. They're community resilience and health, Arctic systems interactions, sustainable economies and livelihoods, and risk management and hazard mitigation. And the plan's also informed by 5 foundational activities, which are across the bottom in blue. They're data management, education, training, and capacity building, monitoring, observing, modeling, and prediction, participatory research and Indigenous leadership in research, and technology innovation and application. So building off of this framework in the Arctic Research Plan, the implementation plan includes objectives, which are very specific research, or they're pretty specific research actions that advance the goals of the Arctic Research Plan. And then it also includes deliverables, which are tangible, measurable, and easily communicated research products that demonstrates progress made towards achieving the objectives and goals. And then we make these products and available to decision makers and partners across IARPC. So we have in this biennial implementation plan that we're currently implementing, there are a total of 21 objectives. Each objective identifies deliverables, which again are research products to be achieved in the next 2 years. This implementation plan has a total of 90 deliverables, and they're centered around supporting research. So for example, initiating funded projects with local partners, creating products. So this could be a report or a synthesis or a tool, and coordinating information sharing. So for example, this could be in the form of team meetings or workshops. So now that's sort of the more general overview. And now I'll highlight some of the actions in this new implementation plan that are more relevant for the physical oceanography community of practice. But I do recommend kind of looking over the whole plan. The areas I'm going to go over are areas that this community is specifically tagged in, but I'm sure that your interests and your works are relevant to a lot of different areas. So always helpful to take a look at the whole thing. So first, our second priority area is Arctic systems interactions, and it has the goal to enhance our ability to observe, understand, predict, and project the Arctic's dynamic interconnected systems and their links to the Earth system. And objectives under this priority area focus on advancing understanding of Arctic amplification and the associated connections with lower latitudes, observing, understanding, predicting, and projecting Arctic ecosystems change and the associated impacts on humans and the entire Earth system, and understanding interactions between social, ecological, and physical Arctic systems, particularly in the context of coastal climate and cryospheric change. So the physical oceanography community of practice is tagged under deliverables under all three of these objectives, objectives. And I'm not sure how to put this in the chat when I'm presenting, but I will put in the chat, or maybe Meredith, you can, a list of all the deliverables under each of the areas I'm going to go through where the physical oceanography team is tagged, but just to highlight a few deliverables that are that have been tagged by the physical oceanography community of practice. One of them is to hold cross-collaboration team meetings and workshops and produce publications to explore results of high resolution and regional Arctic modeling. And these meetings will focus on the importance of model resolution to capture Arctic amplification and its relationship with the lower latitudes. Another deliverable this community is tagged in is to continue coordinated interdisciplinary Arctic marine climate and ecosystem observations and share data and promote synthesis of field operations. And another is to improve high resolution models' ability to capture coastal processes that at the interface of ocean, land, and atmosphere by supporting targeted collaborations among model developers, users, and decision makers. Our fourth priority area, risk management and hazard mitigation, has the goal to secure and improve quality of life through research that promotes an understanding of disaster risk exposure, sensitivity to hazards, and adaptive capacity. And objectives under this area focus on summarizing currently available data and information requirements associated with hazard and risk mitigation, adaptation and response efforts, synthesizing community-led activities and information to identify potential needs for future efforts, updating and improving the statewide threat assessment, which is the identification of threats from erosion, flooding, and thawing permafrost in remote Alaska communities, and conducting and supporting research for more resilient and transformative infrastructure to withstand potential impacts from acute and long-term hazards. The physical oceanography community of practice is tagged under the first two objectives on this work. Some of those deliverables include conducting a study to identify where information used in decision-making and planning can be improved through access to new or additional data sources. And the other is to undertake a study to identify the top 10 threats or hazards to communities and critical remote state and federal government infrastructure in the state of Alaska that should be included in the statewide threat assessment. The Data Management Foundational Activity Collaboration Team is working to encourage and implement fair and care management, data management principles in the Arctic. And the Physical Oceanography Community of Practice is tagged under their fourth objective, or their fourth deliverable, which is to convene quarterly seminars, discussions, and training on fair and care data management in the Arctic, and ensuring a diverse group of presenters and contributors are represented in these activities. And then finally, the Physical Oceanography Community of Practice is tagged under all of the deliverables in our participatory research and Indigenous leadership in research foundational activity. And they are focusing on work to fulfill federal requirements to consult with federally recognized tribes and Alaska Native corporations, engaging Arctic communities and individuals in research in a way that's meaningful to them, and developing guidance for agencies to consistently apply participatory research and Indigenous leadership in research. So again, you can look at the website for a full list of every single deliverable where the Physical Oceanography Community of Practice is tagged. And these are some kind of key examples from across the implementation plan. And like I said, we're currently implementing this first implementation plan. We're going to start the process of updating it late next spring. The update process will be a lot less extensive and kind of happen over a shorter period of time. But that's another way to kind of engage when we start to update, to think about if there's things that are missing or things that should be tweaked. We will begin that process next year. And then that updated plan will be released in November 2024. And we will be sharing a lot more information about what that process looks like in the coming months. Yeah, so that's what I've got for you. I'm happy to answer any questions and appreciate you all engaging with IARPC and on these important research questions. So thanks, everybody.
Thank you, Serena, for your presentations. I would suggest maybe we can go through all the speakers and then have questions at the end to collect everything together. So next up, Tartus Marcus from NASA. Thorsten, if you.
Yeah, hi. Good afternoon or good morning, wherever you are. So I'm Thorsten Marcus. I manage the cryosphere program at NASA headquarters. I am also the program scientist for the ISA-2 mission, the Crystal mission, the Earth System Explorers, as well as the National Snow and Ice Data Center. So, changes in the Arctic Ocean, especially the decline of the sea ice, are among, obviously, the clearest harbingers of climate change. And, maybe directly related to priority area 2, while a lot of science is happening in the Arctic Ocean, funded by NOAA, by NSF, by NASA, by, the ONR, Office of Naval Research, many of the processes are still not sufficiently understood. And models still have a hard time replicating, for example, the summer sea ice cover. Models still not predict it, and there are various reasons for it. And, and then it's largely because our understanding of ice, atmosphere, oceans interactions still need to improve. And in the Arctic, there are many small-scale processes, for example, melt ponds, that have large-scale implications, which makes it very hard to model. We're still using kind of rough parameterizations for those processes. And because those processes are small scale, change on a short time scale, they're very hard to observe. Especially the marginal ice zone, for example, where a lot of action is happening. It's hard to observe, it's hard to model as the sea ice reacts so rapidly to the changes in atmospheres and ocean atmosphere and ocean conditions. So at NASA, Arctic physical oceanography is generally covered and supported via several programs. There is obviously we do have Physical Oceanography program, which is led by Nadia Vinogradova-Schiffer. We have the Cryosphere program that I manage. We have the modeling analysis and prediction program, which is managed by David Considine. We have an interdisciplinary program. We have the OBB, Ocean Biology and Ocean Biochemistry program. And then we have lots of mission science teams like SMAP, SWAT, ISAT-2 that provide relevant data for the Arctic. We also had a longer-term effort called OMG, Oceans Melting Greenland, where the focus was on understanding how the ice sheet and the adjacent ocean interact with each other. It was an effort that used airborne data, that used gliders in the ocean to better understand what's happening under the outlet glaciers of the Greenland ice sheet. And we also had supported a field campaign last year called SASSIE, SASSIE, which stands for Salinity and Stratification of the Sea Ice Edge, where people collected data of the sea ice, of the ocean underneath, etc., to better understand what's going on at the marginalized zone. Because, as I said in the beginning, those are the processes that are so hard to model, so hard to observe. And we support, within the Cryosphere program that I manage, we support a lot of efforts that deal with sea ice ocean interactions, often using remote sensing data, but we also support a lot of modeling. So I don't know, you probably know this, scientists can apply for funding, uses our annual ROSAS calls. ROSAS stands for Research Opportunities in Space and Earth Sciences, which comes out every February. And I encourage you not to look at the physical oceanography opportunities, but there are other opportunities like Ocean Surface Salinity Team, Ocean Surface Topography Team, the modeling calls that are coming out, the Cryosphere calls that are coming out, and reports like the IARPC research plan, like the IPCC report, are often mentioned in our calls because they guide us, to what we should be funding, what we should be focusing on. So these efforts like IARPC, IPCC, obviously, CLIC, Climate and Cryosphere, those reports are very important to give us the guidance of what we should supporting. So we often mention those reports like the Arctic Research Plan, the IARPC Arctic Research Plan in our calls. For the scientists of you, all of our satellite data and derived geophysical products are publicly available via our data centers. For physical oceanography, we have the Physical Oceanography DAC, the Distributed Active Archive Center at JPL, or it's for the cryo data, it's at the National Snow and Ice Data Center. As I said, all those data are freely available, all those products are freely available. And I realize sometimes that less people know about them at times that I expect. So I'm just making another announcement. Please check out the data. And you can also go to earthdata.nasa.gov to check out what data are available to the public community. We have an open data policy. So all data that are collected through NASA funds are publicly available. That includes airborne data, in situ data, etc. So they are all publicly available somewhere as well, depending on on the discipline. And I think that's my 5 minutes. I can talk forever, but I want to stick to my 5 minutes.
Thank you very much, Thorsten, for your presentation. I'm a big fan of the NASA data, and I've been using them a lot, so I will have a question about it later, probably. Next up is Danielle. Are you there?
I am. Thank you for having me. So hi, my name is Danielle Dixon. I'm a program manager with the North Pacific Research Board. So we are not a federal agency. We are an organization that provides funding for marine science research in Alaska waters. And our mission is to fund research to address ecosystem information needs and pressing fishery management needs. So I'll just highlight a few things for this group to think about that I hope will prompt some conversation during the breakout or during, afterwards during the Q&A, and prompt you to think about some ideas for your next proposals. So NPRB is interested in a number of things. But for example, where there are some clear intersections with the IARPC Arctic Research Plan and the Biennial Implementation Plan, things like opportunities to support co-production of research with Alaska communities and research that's relevant to communities, including projects that cooperate with community-based observers. So some examples about, of where communities might be interested in collaborating with the physical oceanography community of practice include things like looking at how physical oceanographic conditions, including water temperature, stratification, light penetration, and nutrient inputs from the terrestrial system, influence the magnitude, location, and timing of harmful algal bloom events that have pose some real threats, not only to the marine ecosystem, but also to people living in the Arctic with respect to food security and health, for example. Another example might be how interactions among the ocean, the sea ice, and the atmosphere influence sea ice stability and sea state that affect the safety of Arctic community members when they're going out to do things like subsistence harvests that affect their own safety, but also the food security of the communities that they're providing for. And then NPRB is also quite interested in opportunities to support multidisciplinary collaboration to better understand things like the factors influencing the distribution, abundance, and condition of marine species, for example, Pacific cod, walleye pollock, crabs, salmon, protected marine mammals, and seabirds. So think about how the physical oceanography community of practice could perhaps provide indices that are relevant to monitoring these resources. And can we advance capacity for forecasting on timescales that are more relevant to fishery management and other resource management? We also, I think, need more information on winter and early spring oceanographic conditions that influence marine ecology, and maybe some technology development that could make that information more readily available on timescales that are relevant for management. So sea ice cover poses a real challenge to telemetering data from the ocean in near real time in the Arctic. So often we have moored instruments that sit on the seafloor, and the data are collected once per year. But by the time fishery management has that information, they've kind of missed the mark for setting management for managing the resources. And then the other thing I put down in my notes is just always the interest in improved understanding of exchange between offshore and nearshore ecosystems. We have people that do research in offshore, and there are people that do research in the nearshore, but really making those connections between offshore and nearshore conditions and how they affect the resources that people are trying to harvest, for example. So that's what I wanted to say with my 5 minutes. I'll just really briefly hit on some things that North Pacific Research Board is funding now, and the programs that we offer funding under. I manage an integrated ecosystem research program. So these are programs that kind of bring together a number of scientists to collaborate over a scale of maybe 5 or 6 years to really look at those marine ecosystem processes in detail that connect the physics and chemistry all the way up through the food web. And so we recently had an Arctic focus program that focused on Bering Strait and the US Chukchi Sea. And that one's finished now. If you look at our website, nprb.org, you can see all the data collected by that program and the reports and some videos about it. And we're in a synthesis phase right now. And Sandy's program, which she's going to talk about, is co-funding that synthesis. So it's taking field data collected by our program and others, and using them to update models, so ecological models and models that look at nutrient dynamics that fuel primary production, for example. And we're about to launch a new Northern Bering Sea focused integrated ecosystem research program, and we expect to release a call for pre-proposals next month for that program. So that'll be kind of our next decade of research in the integrated sphere. We also offer funding under a long-term monitoring program. So for example, for 10 years, we've been funding a Chukchi Ecosystem Observatory. It's an array of moored instruments in the Northeast Chukchi Sea. So that's kind of relevant to this program, I think, and what we're talking about today. And then we also offer a core program that provides funding on a mostly annual basis. And there is a category for oceanography and lower trophic level productivity. And under there, we provide funding on a more regular basis for smaller scale projects, 2 or 3 years, to look at something specific. So I encourage you to look at our website, and I'm happy to take questions later. Thank you so much.
Thank you, Danielle, very much. And last but not least, we have Sandy from NOAA.
Yeah, thanks. So Meredith, Meredith is going to show some slides for me. This is my first time engaging with the physical oceanography community of practice. So I thought I'd give a bit of an introduction to GOMO's Arctic Research Program. The Arctic Research Program within GOMO, the Global Ocean Monitoring and Observing Program Office, we're a smaller size program compared to others at NOAA. I'm the new director. My background is in physical oceanography and atmospheric sciences. Before coming to GOMO, I was at the Climate Program Office under the Climate Variability and Predictability Program. So you may have heard my name through that side. But I came on board at the end of last year, beginning of this year, and I'm still getting up to speed on a lot of things. So I'm looking forward to having a rich discussion today and seeing all the connections that are going on through IARPC. My program management team are David Allen. He's the senior program manager for ARP. I'm sure you've engaged with him a lot across the different communities of practice in IARPC. The second program manager newly hired on is Cindy Garcia. She's taking on some new roles this year, different from when you probably engaged with her last time. She was a Knaus Fellow, working with some of the community of practices in the Secretariat. Additionally, Sarah Tucker is our Knaus Fellow for ARP this year, and she's taking on the Field Operations Working Group or Community of Practice Vessel Matrix website and planning. So I hope you've engaged with her in the past as well. So that's our ARP team, as I said, within GOMO. Next slide. And I'll be talking not only about GOMO in the first set of slides, but also another program through the Climate Program Office. So the Arctic Research Program, it aims to improve the fundamental understanding of ocean, ice, atmospheric processes, and the marine ecosystems in the Northern Bering, Chukchi, and Beaufort Seas. And this is really to characterize the response to climate variability and change. The Arctic Research Program also supports NOAA mission capabilities across the Arctic through our targeted and sustained observing, through the investment in model improvement, and the use, synthesis, and science communication efforts. So next slide is showing the portfolio. And this can really be broken into sort of 4 areas of our major investments. So the first is the ecosystem and fisheries oceanography coordinated investigations. It's EcoFoci. That has both long-term observations in it, some modeling work, and connections out through the fisheries decision that Danielle was recently talking about in the synthesis efforts. That's tied in hand with a distributed biological observatory. They have shared cruises and shared observation products. So they're really looking at the cold pool formation, the impacts on fisheries, changing sea ice locations and those impacts, and the emergence of harmful algal blooms in areas that were previously unknown in the recent past. And that also includes a individual project called the Arctic Marine Biodiversity Observation Network, or ANMOM. So the second major area under ARP is modeling and improvements to modeling. And I should say that the ecosystem and fisheries, the EcoFoci group is mainly at PMEL and at the Alaska Marine Sciences Fisheries Center. And the next set is for the Arctic modeling and model improvement. Those are through two teams. One is at the Pacific Sciences Laboratory at NOAA's PSL in Boulder, Colorado. The second is at GLERL, the Great Lakes Environmental Research Lab in Ann Arbor, Michigan. So the PMEL group has CAFS, the Coupled Arctic Forecast System, and that work is advancing quickly and transitioning in the next couple of years through to NOAA's newer UFS, Unified Forecast System. So those are things that they're working on, the high resolution coupled sea ice models for operational forecasts. And the work at GLERL is looking at the sea ice routes, or the shipping routes through the Arctic Ocean area. So that's information for shipping, transportation, and weather forecasting. Another major area of the ARP portfolio are observations, specifically for sea ice. We fund the coordination of the International Arctic Buoy Program. We also have the sea ice SIMBA, sea ice mass balance buoys in the high Arctic, as well as we are the core funder for the program office and director of the U.S. Arctic Observing Network, USAON, which is coordinated here through IARPC, and that's identifying the contributions of the Arctic observing systems and really defining shared Arctic variables and connecting with the international level through SAON and the Rhodes process. And then last but not least, we have our communications and transitioning all of the great Arctic science that's going on through the NOAA's Arctic Report Card. It's a peer-reviewed and highly publicized accounting each year of the yearly change based on Arctic observing. And it comes out as a series of essays and topics that have three areas. One is a core set of variables that are looked at year over year. The second area is emerging topics. And then the last area is updates on topics that get refreshed every couple of years. So that's frost bites, indicators, and the consistence index. So next slide. So you asked about where our future opportunities and plans are for the Arctic Research Program. This is specific to my program. We are interested in sustaining the long-term observations and developing and evaluating new observational techniques as the budget allows. We're investing in modeling needs, both with a focus on NOAA's missions, but also supporting the societal connections through transportation and the needs of the Alaskan and Arctic region. The next is that we are making sure that that our data is helping to support fair and care practices. We've recently expanded the ARP website to include data landing pages, which makes a more accessible path to the data that the Arctic Research Program is developing, a path so that people can find our principal investigators' data more quickly. We're also supporting relevant and ready-use products. We're expanding our meaningful engagement with Indigenous and coastal communities in Alaska. We have an opportunity to engage through our partners at NOS with several community groups. And if I can give you details of that offline. The last is improving our partnerships both within NOAA across OAR, NOAA, and between our agencies like through IARPC, plus internationally through our other groups. So next slide. And this is the transitioning to the Climate Program Office, which is a different program office from where I'm sitting. The Climate Program Office has a program called the Climate Variability and Predictability Program. The program manager there is Ginny Seltz, that's her email. And I wanted to alert this group that there is a current call for proposals out. And the Climate Variability Predictability Program is the process level understanding of the physical climate system. So that includes ocean, atmosphere, land, and cryosphere, so fairly broad. But I wanted to highlight that they do have a call for proposals for fiscal year 24. It's due in mid-November. The date for the letters of intent have already passed, but you could reach out to Jenny if you have a project that you think that might be appropriate for this call. The title on it is Advancing Understanding of Multi-Year to Decadal Climate Variability and Predictability for the U.S. Climate Prediction. And I highlight this because it does explicitly, amongst the other key processes, call for cryosphere. And the link to that funding opportunity is there. I'm going to circle back a little bit. Right now, the Arctic Research Program does not have any open calls for proposals. We mainly do core and directed funding, but hopefully in the future that will change as funding becomes available. That's of interest to us. So next slide. I wanted to do just a crosswalk quickly on supporting the IARPC PO deliverables. So Arctic engages in work for Arctic amplification. So specifically on 211, we have studies that are the impacts of atmospheric and oceanic circulation on Arctic amplification and on connections to lower latitude weather. We have a large suite of projects that are on studies of AMOC. We also support 2.2, the Arctic ecosystem change, and that includes products, meaningful products for 223, such as the Arctic report card. We also have the interdisciplinary studies under 224 for ecofoci and DBO, just calling out 2 examples. There's many more. And we also have a suite of publications and products through many of our service delivery and through our core ARP projects. We also have efforts towards climate and coastal modeling, observing, improving those models under 237. And of course, we align with Data 1, the access to fair and care. Plus, we support Pillar 2 with engagements through communities, specifically through NOS. Next slide. And I think it's maybe strategic that I'm going last here because I put a slide in for discussion topics. I'm new to the IARPC community, the physical oceanography group as well. And I'd really like to kick it off with, what do you as our community see your roles in the work for ARP, CVP, and the other programs at NOAA? Where do you see yourself? Where do you see the community at large? What's working well? What could be improved? And if you don't have time or if that's not of interest for the co-chairs here, feel free to email me or the ARP team. Our emails are there. Look forward to engaging. Thanks, everyone.
Thank you, Sandy, and thank you, everybody else, for your talks. I think we are opening the floor to anybody who has questions. I would take advantage of me being the first one to speak to ask a question, actually, if I can. You all mentioned a lot of observation and observational systems and sustained observations. And one question for me is, as a physical oceanographer, we would like to use them as much as possible. You have a big picture on what is done and what are we doing and how well are we using the observation. Do you have any feedback on that? Do you think there are gaps that we should look into about using this observation to inform our studies? Or do you think we're actually doing a good job? I think we are open for criticism in case. I don't know who wants to start, but that was my question. We are doing it.
No. It's funny. It feels to me it's a question for the community, because I would be really interested in hearing, are those data useful? What data are, especially useful? What are, the data needs? If you tell, I was like, when we did the year of Arctic prediction, there I was marginally involved, but it was a discussion about what do we need to do? What observations do we need to have to, this was all small scale, a short scale. It was weather scale. YOP was weather scale. But it was great to have that discussion with the community. What data are most critically needed? And one outcome, remembering talking with people from ECMWF, was near surface winds. It's so difficult. It's so difficult to observe. And, as you know, it affects sea ice draft tremendously. If the near surface winds are wrong, your best model, sea ice rheology doesn't help if the forcing is wrong. And so that's something, I'm very interested in. And we have, a call out for mission proposals, and near surface winds is actually an observable identified by the decadal survey from the national academies to, hey, can we do something, about near surface winds? So I'm just throwing out this as an example, because I would be really interested in hearing, what do you need? And where are our data to cores, in terms of resolution, in terms of temporal resolution as well. So I think it's an excellent question, but I was going to throw it back to you, Al.
Yeah, fair enough. And anybody?
Yeah, I agree with Torsten that hand in hand we have to answer these questions together, meaning the agencies and the community. I hear feedback from all the time that it's for large scale models, it's really difficult to ingest point measurements. And therefore it's not worth the time and effort to try to even take that on. But I also hear the flip side, which is, how can you model something if you've never observed it or are not observing it well in a high quality? So it's a chicken and egg problem, but getting a set of requirements and directions and needs from the community can be very powerful in driving the direction of the community to really help support this area. And I know that Arctic is not an emerging research topic. However, it oftentimes feels like it keeps reemerging year over year as hot topics come up. So I feel right now that Arctic is going to be getting a lot of focus, if not, focus in the rapid changes that are happening and the impacts that are really beginning to come clear as the rapid changes are beginning to set in. So I think we need to be at the ready to understand our sustained observing networks, and I think we need to be at the ready to take on some of that maybe heavy lift of talking about what or not only talking about, but producing the answers for what are the needs for observing in the Arctic and Alaskan waters writ large. So looking forward to engaging.
Any comments from the participants? Wibert?
Yeah, I mean, it's clear that the Arctic is really kind of underrepresented, right, in the observation space. I mean, it's really hard to get, at least for the physical oceanography part, it's really hard to get satellite observations, of course, in these ice-covered regions, and the Argo network doesn't really work there. So there's a very significant data gap in the Arctic compared to the number and the techniques of observations that are available for the rest of the ocean, basically. So from a modeling perspective, I would definitely be interested to hear opinions about what other technologies can be used to observe Arctic Ocean. And of course, isostatic profilers are one option, but very sparse, of course. So very interested to hear more about this from the rest of the community.
One question maybe what would be, comes to mind to me is what the best way to interact, to somehow submit our requests to physical oceanographers. Is it just simply get in touch with you and have a phone call, or which is, I think, a very good way, or is there ways to participate to bigger projects or calls to, I think that everybody will be interested in knowing how to better contribute to these efforts, to coordinate, essentially as a coordination problem.
Well, again, I'm new to IARPC, so maybe this is my question to you as co-chairs. Does IARPC's physical oceanography community of practice develop and write recommendations for future work, such as the observing needs? Are you making recommendations to the agencies through your groups?
I will leave this one to Wilbert. He has been here for longer.
I guess we have not. Of course, we are. There is this the MOM foundational activity that I think David Allen is co-leading that. So maybe that is something that we, as the physical oceanography community, should be more active in trying to make those kind of recommendations. I noted at the U.S. Climber Summit that we had a couple of months ago in Seattle, this topic about data sparsity in the Arctic came up, and with some colleagues of the POS panel, Dmitry Dukovskoy in particular, we're kind of interested in developing maybe a workshop to address this problem head on, and this might be a good forum actually to come up with maybe a kind of white paper or a set of recommendations for funding agencies on how we can address this topic in more active terms than we have been able to do with this IARPC framework.
I really feel I've been talking too much, so if there is anybody else who... Jonathan has appeared.
Well, yeah, I have to go to another meeting, but I just wanted to thank you actually for putting this on, and especially on behalf of the more junior early career researchers. I think this is a really useful thing to start this conversation and sort of continue it going too. I think there's a lot of interest. So anyway, I just wanted to say thanks, and I have to run to another meeting.
Thank you very much. Wilbert, your hand is up again. Is it from before or?
No, this is new. I don't want to hog the time either. I do have a question for Thorsten. It might not be in the program, but in your portfolio. But I was wondering if you could say a few words about the NASA Arctic Colors project, the interdisciplinary Arctic coastal activity.
Totally fair question. I don't want to talk too much about it because I don't know too much about it. Fair enough. That's spinning up. It's managed, as you may know, by Laura Lorenzoni, who runs the ocean biology and ocean biochemistry effort. It's a good. I don't know too much about it to have a good answer, and I don't want to say the wrong thing. Sorry about this.
That's all right. Thank you.
No, certainly.
So one thing, Renu Joseph, she was supposed to be here, but she couldn't make it today, unfortunately. So she was supposed to represent the Department of Energy's interest in the Arctic oceanography. Jackie, do you want to talk a little bit about CAMAS, which is an activity that is funded by the Department of Energy's Office of Science, Renew's RGMA program that we're organizing for the Highland Resident team?
Sure. So we're organizing a new series of workshops, annual workshops. It's this new program. It's sort of modeled after the previous AOMIP and FAMOUS programs, if you remember those. And it's called CAMAS, the Consortium for Advancement of Marine Arctic Science. And the first workshop is going to be in Santa Fe in February, on February 13th through 16th. And it's going to have an early career school the first day. So there's some funding for students and early career people. And then we'll have a workshop afterwards. And so it's sort of, getting together to come up with, sort of collaborative ideas, ways to advance any kind of Arctic marine science in the Arctic. So I'll put a link in the chat if you'd like to take a look at our website and hopefully register. It looks like Wilbur just did it. So Yeah, and if you have any questions, just feel free to contact the organizing team that's on the website. Hope to see some of you there.
Thank you. So, unless there is anybody else with questions, we have 5 minutes to the hour. So, to me, it has been super interesting. I think to everybody too. I speak for myself. So, thank you again to all the speakers who came to the meeting and introduced the programs. And thank you everybody for coming in and participating. And we are looking forward to, first of all, collaborate with different program managers and agencies, and also for the next meeting, which is going to be in October, if I'm not mistaken. I don't remember the date, I think the 5th of October, right? So,
right.
Perfect. Okay. Thank you very much, everybody, again, and hope to see you soon. And again, thank you very much to the speakers. Thank you.
Yes.
Thank you.
Very much appreciated. Thank you very much.
Thanks for inviting us.
Bye.
Hey.